Thank you for your interest in taking some time to learn more about PDC drill bits. We hope you find this information interesting and useful for your business. If you have any more questions, never hesitate to call Palmer Bit Company, a proven market leader with their Diamond Devil PDC bits and Red Devil drag bits. PDC bits are made of the hardest man-made materials, designed to endure extreme drilling conditions. There are many variants of PDC drill bits, varying by manufacturer and how they are designed for certain drilling conditions. The PDC discussions here are for bits designed to drill in formations such as shale, limestone, and sandstone, where they perform exceptionally well. We will spend the next few minutes talking about the makeup of a PDC bit, their design attributes, and finish with some basic drilling parameters. PDC stands for polycrystalline diamond compact. In essence, PDC bits use a round diamond wafer bonded to a carbide base as the primary cutting mechanism. Bit designs vary by manufacturer and purpose, but in general are used in a similar fashion to standard drag bits. The diamonds are nanocrystallites or polycrystalline based and have the benefit of being long-lasting as well as self-sharpening. Synthetic diamond is 150 times more abrasion resistant than carbide. Developed by GE in 1977, these diamonds are commonly supplied as a mass-produced synthetic component forged under a very high temperature and pressure to make precision diamond wafers. Ask your PDC bit supplier if they are using leached PDC diamonds. Leaching is a critical process step that dramatically increases the longevity and performance of the bit. There are many suppliers of diamond cutters. Many are of suspect quality. Always ask. The wafers are then mated to carbon bases. This carbide base serves two functions. First, they provide for a solid mechanism for supporting the diamond wafers. Second, it provides a method of attaching the diamond to the bit body, since you can't solder or weld diamonds. The goal is to provide both a durable cutter while maximizing penetration rates. The diamond component and carbide substrate of the PDC bit is called a cutter. They come in three main sizes of 1608 or 16 millimeter diameter and 8 millimeter high, as well as 1308 and 1316 variants. Palmer Bit primarily uses the 1308 variant cutter. These variants, when seen from the side, show how the thickness of the diamond varies as it's bonded to a substrate. This isn't the full picture of a diamond table, however, as we will show in a few minutes. The other important feature of the diamond cutters is the chamfer, which is the angle of the beveled edge of the diamond. This angle has a significant impact on the bit design and performance. Here you see a non-chamfered edge or a 0-degree chamfer. These are not commonly used and would only be used in soft ground, as they tend to be prone to chipping. Likewise, here's a 12-degree. Though a faster penetration option, they are still prone to chipping easily. This is a 16-degree chamfer, which is a commonly used variant on the Palmer Diamond Devil bits. They offer a perfect combination of durability, yet are fast penetration. And finally, a 20-degree chamfer. This option tends to be very durable, but do have a slower penetration rate. These can be used in harder formations and can be special requested from Palmer if your formation requirements need such a cutter. Here is a side-by-side comparison of these four chamfer options. Differences are subtle to the eye, but very important to the performance of the bit. The carbon base is critical to the performance of the cutter. Always ask your bit supplier or bit salesman about the supplier and quality of the cutter components. High quality cutters are bonded to ideal bases with precision grids, as seen here. However, as you can see here, poor quality bases will make for an overall poor quality cutter assembly. Although cutters are made from very tough diamond materials, their performance can be affected by normal use over time. Here are some examples of wear and chipping. In such cases, these bits should be returned for rework and have the cutters replaced before further damage to the bit results. Drilling with PDCs in gravel or hard formations such as quartz or granite can also have very negative results and damage your bits quickly. High temperature induced damage can also happen if the PDC bit is run under too much pressure or speed, or if the cooling fluids are not sufficiently circulated. Here too, these bits should be returned for rework and have the cutters replaced before further damage to the bit results. Inspect your PDC bits before using. Damage, as seen here, is likely from running in gravel and is not further usable. These cutters still look like they are in good condition and are suitable for drilling. High-quality PDCs, properly maintained and used, when used in ideal environments such as sandstone, have been documented to last a very long time. This example was used to drill more than 72,000 feet. Now, let's explain in a bit more detail regarding PDC bit design, specifically rake and drag. Rake refers to the angle of the cutter to the vertical axis. Drag refers to the change in angle of the wings from center to outside edge. The combination of these two affect the performance of the drill bit. Here you can easily see the rake angle, typically 10 degrees. And here you can see the drag, or change in angle between the two outside cutters. The outside cutters take the brunt of the drilling, since they are the farthest out and cut the widest swath of the drill pattern. This angle change helps promote durability of the bit cutters. In this example of a 5-wing oil-filled PDC, you see how drag is accomplished by adding a twist to each of the wings. These tend to be on very high-end, high-cost bits. In other PDC designs, you can see the twist allow for a leading edge or blade advancement section accompanied by several different sizes of cutters. This is also an example of a high-end, high-cost oil-filled bit, generally not used with water well or geothermal drilling conditions. We have covered cutters, and now we will talk through the bit body. In general, there are two types: solid body steel and matrix. Steel bodies are a single piece of hardened industrial steel. Matrix bodies can combine several different materials into one body to either reduce cost or improve performance. It is very important to talk to your bit supplier or salesman about any matrix bits you may consider, as there are major quality differences by supplier. The lower price and lower quality bits have low carbon percentage matrix materials and will be very prone to failure, as we will show. Here you can see several versions of matrix body PDCs, with the obvious difference in the two materials. Like any bit, quality is of utmost importance. Here you can see that a wing completely sheared off the bit body. This is from a low-grade, low-carbon based material that is not durable. Serious erosion problems on the bit body come from a low-carbon based matrix material. High-quality PDC bit design and manufacturing is a sum of all parts, including proper preparation of the pocket in which a PDC cutter will be welded to. Proper and precise sizing and depth in a quality bit manufacturing process will increase the lifetime of the PDC cutters. There are many designs of PDC bits in the market. This Palmer 5-wing PDC with 5 cutters provides 15 total cutters, offset from each other wing to provide the maximum cutting surfaces. It should also be noted on this bit that there are very large circulation ports, making this bit design very difficult to plug. The depth of the wing allows for cuttings to be flushed easily as well. This 6-wing PDC has more wings, however, fewer cutters. This also impacts how large the circulation ports can be made and can result in frequent plugging. Note the small junk slots as well. This will result in less than ideal flushing of cuttings. If you have never drilled with a PDC bit before, they are simple to use. As a general rule of thumb, apply only 1,000 pounds of weight on the bit per inch in diameter, which would also include your pipe weight. RPMs are generally 80 to 100, with the slower rates for hard formations. And always circulate at least 10 gallons per minute to keep your PDC cool. When you are done drilling, pressure wash and inspect your bit. Look for chipping or heat damage, which will tell you if you are in formations that may require a different bit. Repairs to chips and minor damage are a much faster and cost-effective approach than replacing worn out or non-functional bits. We see many conversions from hammer bits as well, if the formation you are drilling in works with PDC bits such as shale, limestone, and sandstone. Penetration rates many times are very similar. However, due to the lower energy requirements needed to function in your rig, the fuel consumption needed for a PDC versus a hammer are dramatically reduced. This is money straight to the bottom line. Thank you for taking a few minutes to listen to this presentation. PDC bits are new to many areas and drillers, and in the right formation can be a big performance asset to your drilling process. We would love to hear your comments, questions, and feedback. If you have any further questions, please call us at 800-421-2487 or see our website at palmerbit.com for much more information and testimonials from those who are PDC users in the field.